My name is Vidhanshu and welcome back to another video of DSA with GDSC Bootcamp. I hope you all are enjoying your summer vacations and having fun doing coding. So in this video, we are going to learn about searching in arrays. In previous videos, we learned about arrays, what is it and how to declare it, how to take input and output the array. In this particular video, we are going to see searching. So let's see what is searching. So searching is a technique where we find the value inside a collection of data. Means you will be given with a collection of data, like it may be array, it may be a linked list or any other kind of data structure. Also, you'll be given with a key that you have to find inside that data structure. So this is searching is. So now if I gave you the below array and told you to search an element, how would you search? Let's say you are given with this array. The array is having these elements 2, 9, 8, 10, 15 and 27, and the element which we want to search is 10. So how would we search? You will say, I know it, I'll keep checking the elements one by one until I get the key, like we have shown in this image. What we have to search? We have to search the 10 and the elements are 2, 9, 8, 10, 15 and 27. So according to your answer, what you will do, you will check the element at the first index, which is 0th index. So it is 2 and the element which we want is 10, so it does not match. So we'll increment the index and we'll check the first index, means actually the first index means 1th index, which is the second element. So we'll check if 10 is equals to 9. So we see that they are not equal, so we'll again increase the index by 1. So now we'll check the second index, which will be the third element of an array, which is 8. So we see that 8 is also not equals to 10, so we increment the index by 1. So now we are checking the index 3, which is the fourth element, and we see that 10 is equals to 10. So yes, we found our element. So result will be 3. Why 3? Because this is the 0th index, this is first, this is second and third. So third index is having our target or the key. So we found it. Yes, the approach that you told is correct. This approach is called as a linear search, in which we keep checking the element until we get. So let's code this now. Let's go to our VS Code and code it. So I have opened my VS Code. Let's start coding it. So I have imported my boilerplate and here I'm declaring the same array that we were having there. So the array was 2, 9, 8, 10, 15, 27. So 2, 9, 8, 10, 15, 27, semicolon, the semicolon I need to give. Okay, now the key value which I want to find is 10. Okay, so as I told, we will be keep checking the element by element individually, and from the 0th index to the nth index, where n is the size of the array. So in this case, the size of the array is 6, so I'm storing 6 inside this n. Okay, cool. Now let's implement the function of linear search, which will return the index, and index will be integer, of course. So I'm giving the name as linear underscore search, and what we will pass to this function, we'll pass an array. Now how to pass array to the function? It is very simple. We can, like how we declare an array, like this. The same thing you have to pass here. Then the second thing which we are going to pass is the size of the array. We also need to pass the key element here, so we'll also be passing the key. Okay, now we are looping over this array. So we are starting from the 0th index and we are going to the n minus 1th index. As you can see that it is less than, so n minus 1th index, which will be the last index. And what we will do, we'll simply keep checking in the array of, means ith element of the array, if it is equals to key. Okay, if it is equal, we'll simply return that ith index from the function, and since we have returned the I, we'll no further going to execute this, we'll simply return, and like here we can print that index. Or else what we can do, if we didn't find anything in the array, we'll simply return -1. Means this loop have completely run, means we have traversed complete array. This Like we check it here, here, and all the elements, but we don't found. Like suppose we are searching for 13, but 13 is nowhere in this array. So in that case, we'll return -1. So I hope you understood this code. Now let's try calling that function linear underscore search. So in this function we need to pass array, the length of the array, and the key which we want to search. And remember, we don't need to have this name and the name of the array same. We can give any name, whatever you want. Also for every argument, whatever the name you want to give, you can. So here, now let's try running this program and check what the result we get. So I'm here running the program, and you can see we got the result 3 back, means our key is present at the third index, 0 1 2 3, which is the correct answer. Now let's find the key which is not present in the array, which is 13. So you will be see -1 printing on the screen. So you can see that -1 have been printed here because 13 is not present in the array. So this is what the linear search is. Now let's move ahead and see what is the time complexity of the linear search algorithm. Since we are checking each and every element in an array by comparing it with the key, if they are equal or not. In the worst case scenario, there will be no element in the array which we are finding. So in that case, we need to completely traverse the array. So in the worst case scenario, we are completely traversing. That's why the time complexity of this algorithm is big O of n. Why big O of n? Because n is the length of our array and we are performing the operation of comparing n times. That's why big O of n. Now let's see what is binary search algorithm. Have you ever found the page number in the large dictionary? How do you find the page number that you want? Yes, you got it correct. We first open the middle page randomly, then check if that page number is equal to the page number that we want or not. If not, we check if that page number which we found randomly in the middle, is it greater? If it is greater, surely the page number that we want will be in the first half, will be in this first half. Otherwise, that will be present in the next half. And what we would do is we repeat the steps until we get the page number that we want. So this is how the binary search also works. The previous example that we seen is the binary search. Binary search can only be performed on the sorted data. Why is it so? You can understand it with the previous live example that we see. Because you know that in the dictionary all the pages are sorted, means the second page comes after page number 1. It never happened that the 2 page number comes first and then page number 1. So that's why we need a sorted data to perform this binary search. We'll always be calculating the middle. We'll be comparing the key that we want with that middle, and if that key is greater, our key will be present on the next half. If our key is less, obviously that will be present in the first half. So now let's see how does the binary search works. Let's understand with this image. We are having array of length 10 in which we are having elements in the sorted order. We are having 2 pointers, this low pointer and the high pointer. Actually we are also having this middle pointer, but we calculated this middle value using this low and high. How? We'll see. So the element which we want to find is 23, which is our key element. So our key is 23, and now we have to find this 23 in this complete array. So how we perform this binary search in this case? So we keep low pointer at the 0th index initially, the high pointer at the last index, which will be the size of the array -1, in this case 9. And now, as I told you in the case of the dictionary example, we randomly open the middle element, middle page actually, and then we compare our key with it, and then we keep doing that. So in the same way we are doing here. I calculated the middle using this low and the high. How? I calculated their average, means 0 plus 9 by 2, means low plus high by 2, which is 9 by 2 only, so it is 4.5. But in this case we are doing integer division, so our answer would be 4 only, because that fractional part will be truncated. So that's why we are checking at the 4th index if it is equal to our key or not. So 23 is not equals to 16, but we see that 23 is greater than 16. So since 23 is greater than 16, we need to check this key in the next half. Why? Because obviously since this is a sorted array and the middle element is smaller than the key, our key element will lie in the next half of the array. So what we will do, we'll like update this low to the middle plus 1. Why middle plus 1 and why not middle? The reason being is because middle we have already checked, it is not equals to the key that we want. That's why we are removing this part, because our key surely will not lie in this part from 0 to 4. That's why we are updating this low to 4 plus 5, which is 4 plus 1, which is 5. In this case our low will point to 23. Now what we will do, we will again take the average of the low and high and calculate the middle, which is 5 plus 9, which is 14. So 14 by 2 is 7. So our middle element will be 7. Now at this 7, we'll check if that key and the element which is present at that 7th index, are they equal? No. But our key is less than that middle element. It means that our key will lie in this half and not in this, because key is smaller than this middle. So now we'll update this high pointer to the middle minus 1. Why middle minus 1? Because we know that our key will not lie in this region. So we can update this high to directly to middle minus 1. So our high is now will be at 6. Then we will calculate the average of the low and high, which is 5 plus 6 by 2 means 11 by 2, which is 5.5. So our middle will be at 5. So we'll check if mid is equals to the target or the key that we want. So 23 is equals to 23. That means we found our element, our key value in the array, and we will just return that middle element. So how is it efficient? We are dividing the array into two parts, and we are only checking the first half. That means our array is getting divided into half parts each time. That's why even though we take the large array, very large array, so it will be converted into very small array. So this approach is called as a divide and conquer approach. Binary search is a divide and conquer algorithm. So now let's code this algorithm into VS Code. So here I'm having a file named binary search. So let's code the binary search here, and let's see how to code it. So I'm first including my boilerplate. So I have included the boilerplate. Now let's take the same array that we seen there. So now the key which we want to find is 23, and the length of the array is 1 2 3 4 5 6 7 8 9 10. So the length of the array is 10. Now let's implement that binary search function. So binary search function will return an indeed an index. So the index will have the data type integer. Now I'm giving the name binary underscore search, in which I'll be passing the array, so integer array. Then I'll be passing the key. Then I'll be passing the length of the array. Now let's implement it. As I told you there, that we'll be having these two actually 3 pointers, this low, mid and high. So let's declare those: low, mid and high. So let's store 0 in the low. As I told you that low will be having the first index, then high will be having the last index, which is the size of the array -1, and the mid will be having the average of both. So it will be low plus high by 2. Okay, so we have calculated all the indices. Now our condition, now what should be our condition? Like we can say base condition, but this is not a recursion. So the condition of the while loop we can say, and when we want to stop, because we cannot keep doing this infinitely, we need to stop it somewhere. So when this low pointer will become equal to the high pointer, at this case you can see that we found the element, but let's say this the element which we found, want to found is 24, which is not there. So we'll again find their average of the low and high, which is low in this because this is 23 now. So the element which we want to find is 24, so that will be in the next half. So our low become mid plus 1, which is 6. So now our low and high both will be pointing to this 38, and since low is equals to high, it means that we have to stop the execution of that while loop, because we traversed the complete array and we didn't found that element. So that would be our base case. So I'm writing it here, while low is less than or equal to high. Because why less than? Because obviously we will have to run the loop if that low pointer is less than high. Okay, so now I'm calculating the mid again here. Okay, I have already calculated the mid, so I'm not gonna calculate it here. I'll calculate at the end. So here I can do is I can check if the array of that mid means middle element is it equal to the key that we want. If it is so, I will simply return that mid, because the key we found in the just one comparison at the middle index. So if this is not the case, I'll check. What I'll check if array of mid, that is the middle element, is it less than the key. It is less than the key means our key is greater than the middle element. It means that the element which we are finding is present on the next half. So we'll update the low to low mid plus 1 actually, so that our pointer will point to this. Suppose this is the mid, so it will point to this now. Otherwise there is only one case left, means either the middle element and the key can be equal, either the middle element will be less, or at the last case our middle element will be greater than the key. So I'm not writing the condition here, I am directly writing the else block. So here what I will do high is equals to mid minus 1. High is equals to mid minus 1. So eventually I will return minus 1. But we are forgetting one thing, that we are updating each time the low and high, but not updating the mid. Mid will remain the same. So at the end we also need to calculate that mid again. So this is low plus high by 2. Okay, now let's try to run this program and let's see what we get. So we get the index number 5. Let's check if it is correct or not. So we are going to find 23. So 0, 1, 2, 3, 4 and 5. Yes, we indeed got the correct index that we wanted. Now let's check for the element which is not present, like 24. So if we run this program, we should get minus 1, and yes, we get the minus 1. This means our program and the logic is correct. So this is how the binary search algorithm works. Let me give you brief summary again. So these are 3 pointers that we declared. The first pointer will point to the first memory location in the array. Then the high pointer will point to the last memory location, or the last index you can say. Then we calculated the mid. Either you could do is like you can calculate this mid at the starting only. Here you can calculate this mid here, and you can remove this from here. So if you do like this, it will still work. Let me show you. I'm running the same program for the input which is not present. So you can see that I got minus 1, means it is still working. So you can do either this way or that way, whatever you feel comfortable with. Then after calculating the mid, we are checking if our key that we want is equal to mid element or not. If it is not, we are checking if that middle element is less than the key or not. If it is less, it means that key present in the next half, so we are updating the low to mid plus 1. Otherwise, if the middle element is greater than the key, it means the key is present in the first half, so we are updating the high pointer to the mid minus 1. And eventually, if we didn't find any element equal to key, we'll return minus 1. So this is how the binary search works. what is the time complexity of the binary search algorithm. So in this algorithm, we are using the divide and conquer strategy, in which we are dividing the array size into half and searching over there. Means eventually we can say that we are decreasing the search space by half during each iteration, and we are searching there. So if the size of the array is n, so what we are doing, we are dividing it by 2 until the size becomes 1. So why size becomes 1? Because in the when we implemented the code of the binary search, we see that like we saw that the condition there we wrote was low is less than equal to high. Means eventually the low pointer and the high pointer will be pointing to the same memory location or the memory block. It means the array size eventually our search space will become with the size 1. So that's why we are dividing the size of the array until it becomes 1. So we can write this expression mathematically as n divided by 2 to the power k equals to 1, where k represents the number of times we are dividing n with 2, and eventually it will also tell us how many iterations we required to search. So now this 2 to the power k will get multiplied with this 1, and it will become 2 to the power k equals to n. Now we are taking log to the base 2 on both the sides, so it will become k into according to the property of the log, this k will get here in the multiplication of this log. So log to the base 2 of 2 is 1, so this will become 1, and this becomes log of n to the base 2. So hence eventually our time complexity will become log of n to the base 2. So this is a good time complexity rather than completely searching the array, and with the time complexity big O of n. So now we are going to solve a question on the topic binary search. In the previous video, we have already introduced you with a platform named LeetCode. So if you haven't watched that video, please do check that video and get introduced with this LeetCode platform and get well versed with it. Now let's see the question. The name of the question is guess number higher or lower. We are playing the guess game. The game is as follows. I picked a number from 1 to n. You have to guess which number I picked. Here I means the computer. The computer will pick random number between 1 to n, and our task will be to tell which number is that. So every time you guess wrong, I'll tell you whether the number I picked is higher or lower than your guess. So for this purpose, the LeetCode is providing us an API, which is in this case nothing but a function. API is nothing but an application programming interface. So in this case, the API is this function. What does it do is it takes an integer as a parameter and returns something which is integer. So let's see what is that something, which returns 3 possible results. It will result -1 if our guess is higher than the number that computer has picked. Means suppose there are number from 1 to 10 and the computer has picked 6 and we are choosing 10. So 10 is higher than the number which computer has picked. So in this case, the -1 will be returned. In the same way, it will return 1 if our guess is low. Now it will return 0 if the number that we picked is the number that computer has chosen. So let's see the test case. The test case says there are 2 inputs, but actually this pick input will be given internally that we cannot see. This is just the function that we have to complete. Our task is just to complete this function, and all these inputs will be taken internally, so we will not be able to see this input because this input is only the answer. So that is just we want to find, and we cannot access this. So we'll be just given with this integer variable n. As we can see in the function definition which we have to complete, there is only one integer that we are accepting in this function as a parameter. So we'll be given with just n. So n is 10, means 1 2 3 4 up till 10. These many numbers are there, and computer will randomly pick any number between that, and our task will be to find that number. So how we will find? For this purpose, this API function will help us, whose name is guess. So we'll pass an integer there, and it will return out of these 3 results. So it may be -1, it may be 1 and 0, according to which we can see what we have to do. Now let's see the approach that we are using. So now let's see what is the approach to solve this problem. Let's say n is 10 and the number that computer has chosen is 6. This number will not be provided to us. So let's write the numbers from 1 to 10. 1 2 3 4 5 6 7 8 9 and 10. So these are the number which are given to us. We have to find the number which computer has chosen. So you will say it is very easy. We can keep traversing one by one using the linear search and keep checking that if this giving me the result 0 after passing it to the function guess. So this is the function. It is returning 0 if we found the number. If it will return the -1 if we chosen the higher number. Okay, if we chosen the higher number it will return -1. Okay, this is not looking like a -1, it is looking like a symmetric L. So let me update it like this, -1, and it will return 1 if we choose the lower number than the computer has picked. So you will say that I'll pass this one first into the guess function and I'll check if it is returning 0 or not. Then I will pass this 2 3 4. I will do this until I get the number. But this approach is correct, but like it will be taking lots of time, because as you can see here in this case that constants are 2 to the power 31, which is approximately equal to the number which is order of 10 to the power 9. Okay, so this is a 4-byte number will be there and it will be of order of 10 to the power 9. So this cannot be performed within 1 second. This cannot be performed within 1 second. The number of operations that which we can perform within 1 second are 10 to the power 8, around 10 to the power 8. So if the operations are from 1 to 10 to the power 8, they can be easily performed within 1 second, less than 1 second. But if we just exceed 10 to the power 8, like 10 to the power 9 or something, that will take lots of time to execute your code. So that's why we cannot use the linear search in this case. So instead we are using binary search. And one more reason to use the binary search is that because the data is sorted. You can see that the numbers are from 1 to n, so obviously the natural numbers are there and they will be sorted. So what we can do, we can keep a start pointer, we can keep the end pointer, as we have seen in the video, like how do we perform the binary search. Now let's see, this is our start pointer and this is our end pointer. Now what we can do is we will find the middle one. So 1 plus 10 is 11 and 11 by 2 is 5.5, so it is 5 only, as I told you that we take integer division. So we'll check if this 5 is the number which the computer has picked by passing it to this guess function. But what it will return, since we have chosen the lower number than this is the number which we have actually which we need, so I'm like circling it, but the number that we have chosen is lesser than the number that computer has picked, so it will return 1. So we'll check if it is returning 1. So if it is returning 1, what I'll do, I'll simply move this start pointer to this position, to this position, because this is our mid. So what we do in the binary search is we simply update the start to mid plus 1. So now our start will be pointing here. Okay, now start is no more pointing here, so I'm removing it. Now start is pointing here and end will remain the same. Now again we'll calculate the average of both. So this is 6 and 10 16 and the average will be 8. This will be mid in this case. Now mid is no more pointing here, so I'm removing it. Okay, so now mid is pointing here. We'll check 8 by passing in this function. Is 8 is the number which computer has picked, so it will return me -1 because 8 is higher than the number which computer has picked. So we'll update this end pointer to the mid -1. So now this end will not point to this 10, it will point to this 7. So we'll simply update it at this place. So now this is our new end. And okay, now again we'll do the same thing. We'll calculate the average of both of this thing. It is 13, so it is 6.5. So 6.5 means only 6, so our mid will be here in this case. Okay, now the mid is no more pointing here. Mid has been updated and it is now pointing to this 6. Now we'll pass this 6 into the guess function and we'll check if this is the one that we are finding. So it will return 0 and hence we have found. So I hope you understand how the binary search is working in this kind of question. So now let's code it. as I explained you, I'll be keeping two pointers, low and high, or we can say start or end. So I'm keeping it as a start and end. I'm using long in this case. Not necessary, integer will also do the work because it is under the range of the integer, but still I'm using the long int. So I'm having a start pointer in which initially I'm storing 1. Why am I not storing 0 and I'm storing 1? Because you can see that they have already told that it is starting from 1 and ending to n. So that's why. So in the long, again I'm creating one more variable, long int end. Okay, you can simply write long as well, no need to write this integer again. So if you still write this, it will still work. So n is given to us, so I'm directly storing it. Now we need one more variable here. We need one more variable which will be long mid. So currently I'm not storing anything in it. So while this start is less than or equal to end, as we have discussed in our binary search video, until this start and end becomes equal, we will be running this while loop. What we will be doing, we'll be calculating this mid first. And how we'll calculate? We'll calculate by taking the average of start and end. So here I'm dividing it with 2, so it will calculate the average of those two numbers. Now since we have calculated the average, now let's check if the number which is mid, is it equals to the number that computer has picked. How we can check it? We can check it by passing it to the guess function. So we'll pass it to the guess function, and this will return 0 if this is the guessed one. So either way we can do and compare it with 0, or we can like take note of it, and this if statement will run. So what we'll do, we'll simply return the mid, because mid will be the number that the computer has chosen. Otherwise what we are going to do is, we can check if this guess of mid is -1. If it is equals to -1, what we'll be doing, since it is -1, we know that if it is -1, the number that we have chosen is higher and we need to update the end. We'll update the end to mid -1. Okay, we'll update it to the mid -1. Else the last condition will update the start to mid +1. Okay, now like we have done with this while loop. Now we can simply return -1 at the end, which is not necessary, but if I do run this program directly, it will see that the return statement is inside this if. So he don't know, like the compiler don't know that whether it will run or not. So that's why we need to return something here. So you can return anything just for the sake of satisfaction of the compiler. So I'm running it and let's see whether we are getting an error or not. So yes, our answer is correct. The number that we found is correctly guessed. Now let's check another test cases as well. Suppose the number that is input is 1 and the number which we have to find is also 1. So let's see whether it is giving correct answer or not. Yes, it is also giving the correct answer. Now again check for this third test case by giving the input. So yes, we are getting right answer for all this inputs. Now let's try submitting this code. So yes, our solution has been accepted. I hope guys you understood the question and you got the idea like how to solve the questions on the LeetCode platform. I'll be providing you the link of this question in the description box. You can check this question and you can try solving this question by your own. Thank you so much for watching this video, and I hope you understand both the algorithms, and let's meet in another video.